Hello everyone, today I'll be discussing orthophosphoric acid. Orthophosphoric acid, commonly known as phosphoric acid, is a weak acid with the chemical formula of H3PO4. It's non-toxic in nature, which when pure is a solid at room temperature and pressure. The most common form of phosphoric acid is an 85% liquid solution. These solutions are colorless, non-volatile, and odorless. The 85% solution is a thick liquid. Even though phosphoric acid does not meet the strict meaning of a strong acid, the 85% solution is acidic enough to be harsh. Pure phosphoric acid is a white crystal-like solid with a melting point of 42.35 Celsius. When it is less dense, it is colorless, viscous liquid, odorless with a density of 1.834 grams milliliters. The most commonly used phosphoric acid concentration is 85% in water. Phosphoric acid is commonly used in the removal of rust from metals like iron and steel. Usually when phosphoric acid is applied, it reacts with the rust and converts the reddish-brown iron, typically ferric oxide, to a black-colored compound known as ferric phosphate. It is also often used as a food additive. The acid acts as an acidity regulator in food like jams, cereal bars, processed meat, cheese. In the beverage industry, phosphoric acid is used as an acidulant. It helps keep the check of any bacteria formation. In personal care products, it's used for cleansing products, bath products, fragrances, hair care products, and it's usually used to control the pH levels of these products. And 80% of the phosphoric acid that is produced is used in the production of fertilizer. So phosphoric acid can be manufactured using either a thermal or a wet process. However, the majority of phosphoric acid is produced using the wet process method. So the wet process phosphoric acid is used for fertilizer production. Thermal process phosphoric acid is commonly used in the manufacture of high-grade chemicals, which require a much higher purity. The production of wet process phosphoric acid generates a large quantity of acidic cooling water with a high concentration of phosphorus and fluoride. So this excess water is collected in cooling ponds that are used to temporarily store excess precipitation for subsequent evaporation and to allow recirculation of the processed water to the plant for reuse. So here's the diagram of the process for preparing phosphoric acid. In the first reactor, phosphate rock slurry, sulfuric acid, and recycled low concentration phosphoric acid that represents 9 that comes from the filter are fed to decompose for 2 hours at a controlled temperature of 75 to 85 degrees Celsius. The feeding amount of the phosphate rock slurry and sulfuric acid is 88% of the total feeding amount in the present process. In the second reactor, feeding the first reaction solution and the rest of the phosphate rock slurry and sulfuric acid makes the reaction complete. The reaction is carried out for 2 hours at a controlled temperature of 70 to 80 degrees Celsius, and the feeding amount of the phosphate rock, slurry, and sulfuric acid in the second reactor is about 28% of the total amount. So dividing the reaction solution obtained in the second reactor into 2 parts, among which one part flows into the conversion cell and the other part flows in the separator to produce phosphoric acid, in which concentration of phosphorus pentoxide is 33 to 39 weight percent. In the conversion cell, the dihydrate gypsum is separated from the separator, is mixed with part of the second reaction slurry from the second reactor. Some additional 15% of sulfuric acid is added, which conduct the conversion reaction by introducing steam. So in the conversion cell, dihydrate gypsum is transformed into hemihydrate gypsum. The conversion reaction carries out for 40 to 60 minutes at controlled temperature of 90 to 105 degrees Celsius. So in the filter, after filtering the conversion solution, the filtrate, which contains 24 to 30% of phosphorus pentoxide, is fed into the first reactor. So the filter cake is hemihydrate, which contains 4 to 8% of crystalline water, 18 to 20% of absorptive water, and 0.05 to 0.2% of phosphorus pentoxide. The product can be used for producing sulfuric acid and cement.